Let's do number 11 and 12. 11 is square root and 12 is exponents. So let's look at that. Square root. Why is the square root of 64 8? Well, what that means is 8 times 8 equals 64. Or you can write 8 times 8 as 8, let's put it over here, as 8 squared, which is kind of like the opposite of square root. The idea is you're trying to think of, when you look at the number under the square root sign, what number times itself is going to equal 121. That's really what the square root sign is asking you to understand. So in these cases, the answer is given for all three. The square root of 121 is 11, and that's because 11 times 11 equals 121. Or 11 squared equals 121. So then, of course, for number 14, for this example of the square root of 196, it's telling you that since the answer is 14, that means 14 times 14 equals 196. Now, they have this table, and I can upload this table as a tool in the content of the D2L page. And they show you this other way of looking at it up here. First of all, they're giving you a table of perfect squares. So 11 times 11 is 121. We saw that in our previous example. 8 times 8 is 64. And this happens to be the problem that we're looking at on the test review. So if 9 squared equals 81, then therefore the square root of 81 equals 9. Looking at that example and our answer problem that we had on the test review, I wrote it in these two ways. Square root of 36 equals 6. The square root of 81 equals 9. So if you were to put a square root sign over each of these examples, it's merely 3 different ways of writing that. But the answer for each one is still 6. Square root of 6 squared is 6. Square root of 36 is 6. And the square root of 6 times 6 is 6. Okay, so now you have this. This is our problem here. It's merely asking for the answer of 9. But you do have to understand the concept, the bigger idea, that this here, if we were to put square root signs over each one of these, each answer is still 9. Okay, so beep, beep, and beep. No matter which way you write out the expression, the square root of 36, whether it's square root of 6 squared, square root of 6 times 6, or the square root of 36, the answer is still 6. Okay, so I think now exponents. So what we have with exponents, our question asks for 3 to the 4th power. 3 to the 5th power in this example is, there's your base, the big number, there's the exponent. And what that means is you multiply 5 times. The number 3, you multiply 5 times itself. 3 times 3 times 3 times 3 times 3. You have multiplied the number 3 5 times itself. 1, 2, 3, 4, 5, because it's 3 to the 5th power. So 3 to the 4th power, the question that we are looking at in the test review, equals 3 times, this is also a multiplication indicator sign, and I kind of flubbed up that 3, okay, and then you simply multiplying, and the easy way to look at that is you might multiply those sets first. So then you have 9. 3 times 3 is 9. 3 times 3 is 9. You're still multiplying, and that equals 81. So remember, do not add. It's not 3 times 4. That's not correct. It is not 3 plus 4. It is not 3 plus 3 plus 3 plus 3. And I have seen these different ways people have tried to solve these expressions. This is an exponent expression. You do not multiply the 3 times 4. You do not add the 3 plus 4. And you do not add 3 4 times. You multiply 3 4 times itself. 3 times 3 times 3 times 3.